Okay, in this video we're going to look at the money supply. In chapter 14 of our textbook, we look at the money supply process. Okay, suppose George Jetson, a regular citizen, has a balance sheet and he can own securities, he can have currency, or he can have an asset called checkable deposits, money he deposits into his checking account. His liabilities would include consumer and industrial loans, and then these plus this have to equal. If they don't equal, then these three minus these liabilities would be his net worth. Okay, so what about a bank? A bank has a balance sheet as well. They have required reserves as assets, excess reserves, which are reserves not lent out that could be lent out by the bank. We call required reserves RR. We call excess reserves RE, excess reserves, required reserves. If, for example, the reserve requirement ratio is 10%, and demand deposits is $3,000, then the bank is required by law to hold $300 in reserve. They're required to hold reserves of $300. And then total reserves would be the required reserves plus excess reserves. So if excess reserves are 50, then total reserves of this particular bank would be $350. And then the bank can have make loans to the federal government by buying treasury securities. It is receiving coupon payments from those treasuries every period. It could be making loans to consumers and industry, and those loans would be paying, again, payments, just like treasury securities do. Or this bank could make loans to other banks that need to meet the reserve requirement. Now, the liabilities are checking account deposits. That's kind of funny because a checking account deposit to a bank is kind of like a discount loan that this particular bank has with the Fed, or a loan that this particular bank has with other banks. So if you really think about it, checking account deposits are loans. You can think of them as loans, not unlike a discount loan. In a discount loan, the Fed has lent this bank money. In exchange, the bank has to make payments on these loans or pay them off. Same thing with banks that have lent this particular bank money. Those loans have to be paid off. A checking account customer is basically lending this particular bank money via its checking account. And you can think of these checking account deposits as callable loans, because a depositor can call those loans or withdraw all the money in that account immediately by just writing a check. So you can think of these as callable loans. That's why they're on the liability side of the balance sheet. And then these five things have to be equal to these three things if this bank has zero net worth. If these five things exceed in total these three items, then the bank has a positive net worth. What about the Fed's balance sheet? The Fed is the banker's bank. It has purchased treasuries from banks in earlier open market purchases. So these securities, just like for the bank, are paying the Fed coupon payments. So in the Fed's balance sheet, securities are an asset. The Fed has perhaps made banks a bunch of discount loans. And and those banks have to pay payments on those loans. So that's those loans that the Fed has made to banks is an asset. The Fed's liabilities include security in circulation and reserves. Reserves for a bank are an asset, but for the Fed, they are a liability. You can think of reserves as bank money, and you can think of currency in circulation as consumer or firm money. And the liabilities of the Fed, currency and reserves, are what we call the monetary base, or high-powered money. Okay, let's look at an open market purchase that the Fed conducts with Bank A. When we say open market purchase, we're talking about the Fed purchasing treasuries from Bank A. So the Fed gets securities from the banks. So in the bank's balance sheet, securities rise, in this case, by $100 million. Likewise, at the same time, this bank is giving the Fed its securities in the amount of $100 million. So you see securities fall in value by $100 million in Bank A's balance sheet. Now, in exchange for these securities, the bank gets money. In this case, we call reserves. Bank A has $100 million more in money, cash, than it had before. And so the liabilities of the Fed increased by $100 million because the reserves over here have increased by $100 million. Notice that this side of Bank A's balance sheet has not changed, whereas this side, the asset side of the Federal Reserve System's balance sheet, has increased by $100 million, and this side has increased by $100 million. Because this side has increased by $100 million and this side has increased by $100 million, there's no change in the net worth of the Federal Reserve. Now, the monetary base has increased by $100 million because reserves have increased by $100 million. Okay, what about an open market purchase from the non-bank public? Suppose the Federal Reserve System buys a security from George Jetson, and George Jetson cashes the Fed's check. So George Jetson will have a $100 million increase in its currency. Maybe he puts that in his piggy bank, or loses it between the couch cushions, or it falls between his car seats. George Jetson, like the bank, gives up these securities in exchange for this currency. And those securities go to the Federal Reserve System. Because George Jetson is holding this money as currency that he got from the Fed, the Fed's currency liability goes up by $100 million. Again, the net worth of the Fed has not changed because this increase equals that increase. The assets have not changed for George Jetson because George lost $100 million in securities but gained $100 million in currency. The monetary base increases by $100 million in this case. How about a different kind of a market purchase? And in this situation, after selling his bonds to the Fed, George deposits his check from the Fed in Bank A. So if George's checking account goes up by $100 million and he banks at Bank A's liabilities will increase by $100 million. Because Bank A's liabilities or checking account deposits increased by $100 million, now the bank has $100 million in reserves that it can lend out or not. $10 million of those have to be held as a required reserve. And then if it doesn't lend out the rest of it, then it has $90 million increase in excess reserves. The Federal Reserve's, because this deposit increases Bank A's reserves by $100 million, that increases the Federal Reserve System's liabilities by $100 million. And then because the Federal Reserve purchased these from George Jetson, purchased these securities from George Jetson, its assets go up by $100 million. And in this case, the monetary base increases by $100 million. Okay, what happens if the Fed sells securities to Bank A? When the Fed sells securities to Bank A, the bank has to give up its reserves, its cash, to purchase these securities. So it gains in treasuries, loans made to the Treasury, but it has to purchase these securities with $100 million in its reserves. So that's why its reserves go down and its securities holdings goes up. The Fed sold the securities to this bank, so it loses securities. And because reserves went down by $100 million, the Fed's liabilities decreased by $100 million. And the monetary base goes down by $100 million. So this is what happens when the Fed sells securities to a bank. How about an open market sale to the non-public bank, like, for example, George Jetson? Remember, George Jetson is a non-bank. A bank's cash is called reserves. George Jetson's cash is called currency. And so George Jetson gets $100 million in securities, treasury bonds, but it has to pay the Fed $100 million. The Fed loses $100 million in securities because it sold them to George Jetson. Because George Jetson's currency dropped by $100 million, the Fed's currency liability dropped by $100 million. And the monetary base fell by $100 million. How about George writes the Fed a check in this particular open market sale to him? So the Fed is selling securities to George Jetson, who pays for them by writing the Fed a check. And the check is an amount of $100 million. And since George Jetson banks at Bank A, his checking account goes down by $100 million. And if everything else held constant, Bank A's checkable deposits decreased by $100 million. The reserves falls by $100 million. Bank A's reserves fall by $100 million. And assets balance with liabilities here, and net worth is not changing for Bank A. Because Bank A's reserves fell by $100 million, the Fed's liability for reserves fell by $100 million. And the Fed, remember, the Fed triggered all this by giving $100 million in securities to George Jetson. And this reduces the monetary base by $100 million. Okay, let's talk about a shift from deposits into currency. In this particular case, suppose George Jetson goes into his bank and wants to cash a $100 million check. He gets $100 million he gets $100 million in currency, and his checking account goes down by $100 million. This person's assets have not changed because $100 million increase in currency is offset by a $100 million decrease in checkable deposits. Now, recall that both of these are in M1, in the M1 definition of money, checkable deposits in currency. Now, because George Jetson's checking account balance went down by $100 million, Bank A records that as a $100 million decrease in its liabilities. So you can think of it this way. George Jetson is if he has $100 million in his account, in his checking account with Bank A, and he withdraws all $100 million of it, that's basically a callable loan, and George Jetson's calling in that loan, right? So Bank A's checking account deposits drop by $100 million, and its reserves drop by $100 million. For the Fed, because reserves fell by $100 million at Bank A, and that's considered an asset for Bank A, it's considered a liability for the Federal Reserve System, so it sees its reserves drop by $100 million. But it sees its liabilities for currency and circulation increase by $100 million. So there's no change in net worth of the Fed, there's no change in the net worth of Bank A, and there's no change in the net worth of George Jetson. Here, the monetary base does not change. You can think of it this way. The monetary base doesn't change here because currency increased, but reserves fell. That's like taking sand from one side of a beach and dropping it on the other side of the beach. The amount of sand on the beach does not change. And you got to remember that currency is money held by the non-bank public, consumers and firms, whereas reserves are money held by banks. Okay, let's look at a loan to a financial institution. Here, the banking system needs excess reserves. Maybe it made too many loans and it needs money from the Federal Reserve. Maybe other banks would not give this particular bank a loan. Maybe this is a particular bank, and a bank needs $100 million to meet its reserve requirement. Or maybe this is a financial crisis, and banks in general need $100 million from the Fed in the form of a discount bank loan to meet its reserve requirements. So these banks in total increase their discount loans by $100 million. But this means they have more cash on hand. If this loan is made to help the banks meet their reserve requirement, then excess reserves would not change, but required reserves would increase by $100 million. So this is probably a situation, especially in the case of a banking emergency, where it's not just reserves that are increased by $100 million, but it's required reserves increased by $100 million. Now, because reserves are an asset to the banking system and reserves are liabilities for the Federal Reserve System, when reserves for the banking system go up by $100 million, the Fed's liability goes up by $100 million. And then these discount loans the Fed has made to banks increases its assets by $100 million. In this particular case, the monetary base increases by the amount of the discount loan. Other factors that affect the monetary base include float, which is the bump in the monetary base due to the check clearing process. Treasury moving deposits from banks to the Fed drops the monetary base. Interventions in the foreign exchange market. Open market operations are controlled by the Fed. The Fed cannot determine the amount of borrowing by banks from the Fed. It hinders it by keeping the discount rate above the federal funds rate. The monetary base equals the non-borrowed monetary base if we subtract off borrowed reserves from the monetary base. So this right here is the monetary base, and this is the non-borrowed monetary base. So if we subtract off the borrowed reserves from the monetary base, we can see that monetary base is reserves plus currency. And then reserves are borrowed reserves plus non-borrowed reserves. Borrowed reserves come from discount lending. Non-borrowed reserves are the result of open market operations. Borrowed reserves during normal times is usually really close to zero because, again, the discount rate is greater generally than the federal funds rate. So that discourages borrowing directly from the Fed. So this usually is zero. And then if I subtract borrowed reserves from borrowed reserves, I get non-borrowed reserves plus currency. And that's the non-borrowed portion of the monetary base. So the money supply is positively related to both the non-borrowed monetary base and to the level of borrowed reserves right here. Okay, let's show how the Fed can trigger an increase in the money supply because banks get money from the Fed, and that money can end up creating even more money through bank lending. So in this particular case, with the reserve requirement ratio set at 10% and a $100 million increase in reserves, what's going to happen to the quantity of money in our economy? Money being M1. Okay, in this particular case, First National can lend out 100% of this money it gets from the Fed, because the Fed is giving First National Bank $100 million. In exchange, First National gives the Fed $100 million in Treasury securities. And First National can lend out all of that because this is not a regular deposit. This is not a deposit coming from a private citizen. So it can when it gets this money, it can increase its loans by $100 million. So essentially what's going on here is instead of First National lending this money to the Treasury in the form of holding securities, it switches from lending the money to securities by giving those securities to the Federal Reserve. The Federal Reserve gives its $100 million in reserves, which that bank can then lend out 100% of that to consumers and investors. Okay, when that $100 million gets lent out to a consumer, for example, and that consumer buys $100 million in goods from, say, Walmart. Walmart is going to deposit that money that those consumers gave them into its bank. And maybe Walmart's bank is Bank A. So Walmart overnight deposits $100 million in its bank. Now, the next day when Bank A opens, that bank is required by law to hold $10 million. It can theoretically lend out the rest of it. And it can increase its loans to a maximum of $90 million. Now, when this $90 million gets lent out to consumers who maybe buy a bunch of products from Big Lots, Big Lots till is going to increase by $90 million. And overnight, they want to deposit that increase in the money in the till into its bank. So maybe Bank B is Big Lots banker. So Big Lots deposits money, that $90 million in its till, into its bank. Now, the next morning when the bank opens, Bank B opens, it has to, by law, hold $9 million on reserve. And it can lend up to $81 million out to the public. And so this process continues infinite many times until deposits have increased by $100 million. And reserves have increased by $100 million. And loans have increased by $100 million. The change in reserves here is equal to this $100 million here, right? The increase in deposits is 10 times that. But if you think about it this way, if one way to think about this is if $1 billion or $1,000 million are immediately deposited into banks, by law, how much are they supposed to hold? $100 million. So if we multiply this value by the reserve requirement ratio, we get this $10 million here. Another way to think about that is, rather than multiplying this side by 10%, we can divide both sides of this equation, where this times 10% equals that. We can divide both sides of that equation by 10%. And 1 divided by 10% is 10. We call that 10 the simple money multiplier. So let's derive the simple money multiplier. If deposits go up by $100, right, like they did initially. Let's go back. Here, deposits go up by $100 million in this first round, right? And then they go up by 90, then 81, then yada, 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 right? So if demand deposits go up initially by $100 million, then the second round, this ends up being $90 because 10% of this has to be held on reserve. So this, in the second round, demand deposits can increase by $90 million. And then this ends up being 81, yada, 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 right? Now notice that the exponent of this is 1, and 0.9 raised to the 0 power is 1. So we're essentially multiplying this by 1, which equals that. This is 0.9 to the 1 power. This right here is 0.9 to the second power, and this is 0.9 to the third power. And so we can factor out the 100 here, and we have 0.9 to the 0 power plus 0.9 to the first power plus 0.9 to the second power plus 0.9 to the third power, yada, 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 off into infinity. So the black part of this expression is the black part here. This just means summation. Starting at I equals 0, increasing by 1 all the way to infinity. Now in mathematics, we call this a convergent series. And it just so happens to converge to 1 over 1 minus 0.9. And that is 1 over 0.1. And this is our reserve requirement ratio. And 1 divided by 0.1 is 10. If the reserve requirement ratio were 20%, that would be 80. That would be 80, 80, 80, 80, 80%, 0.8, 0.8, 0.8, 0.8, 0.8, 0.8. So if our reserve requirement ratio is 20%, the simple multiplier would be 5. And so the change in demand deposits equals the change in reserves times the simple money multiplier. Okay, what about the M1 multiplier? Okay. If the propensity to hold currency in currency C, and the propensity to hold excess reserves, and excess reserves is R subscript E, grow proportionally with checking deposits, then we can define the currency ratio as the amount of currency that is being held divided by the demand deposits. And the excess reserves ratio is excess reserves divided by demand deposits. Okay, with these two definitions, we can write this as currency equals this portion, a number between 0 and 1, times demand deposits. So we're just multiplying both sides of this equation by demand deposits. We're doing the same thing here. So excess reserves equals the excess reserves ratio times demand deposits. Now, total reserves is, there's two ways to calculate total reserves. Required reserves plus excess reserves. or borrowed reserves plus non-borrowed reserves. We're going to use this definition, required reserves plus excess reserves. And then remember that required reserves equals the reserve requirement ratio times demand deposits, right? Because if required reserve ratio is 10% and demand deposits are 1,000, then banks are required to hold 10% of that, right? So required reserves equals this part of this equation. Now, by substitution, we get this here, right? Because excess reserves equals the excess reserves ratio times demand deposits. So this is replaced with that down there. Okay, now the monetary base equals currency plus reserves, if you remember, right? And then what is currency? Currency is currency ratio times demand deposits. So I'm replacing C here with what it equals. And then reserves is just the sum of these two products, right? So the currency equals this, required reserves equals that, excess reserves equals that. That's the monetary base. Now I just factored out demand deposits, right? So I have the monetary base equal to the currency ratio plus required reserves ratio plus excess reserves. And then we multiply that sum by demand deposits. Okay. Now I just divided, if I divide both sides by D, its coefficient, I get this, right? So this is the coefficient, right? That's the coefficient. And I want to move the stuff in parentheses to the left side, which I do here, right? So the left side becomes the right side, and the right side becomes the left side, right? So demand deposits equals 1 over the sum times the monetary base. Now we're going to find money as currency plus checkable deposits. That's what we call M1. M1 is mostly currency plus checkable deposits. So M is currency plus deposits. And remember, currency is CR, the currency ratio, times demand deposits. And we're going to pull out the, we're going to factor out the D here. So when we factor out the D here, we're left with 1, right? We're left with 1 here. When we factor out D here, we're left with 1. When we factor out D here, we're left with the currency ratio. So we're just factoring out the D. And you can see this if we distribute this here and here, D times 1 is D, and D times CR is CR times D, right? Now if we solve this for D, we divide both sides of this equation by CR plus 1, the currency ratio plus 1. We do that over here. Now, check out this trick. We can replace this D up here with what D equals. So we got one equation, two equation. We can substitute this for D right there. Now, notice we have M divided by the currency ratio plus 1. If I multiply both sides of this equation by the currency ratio plus 1, I get this down here. Okay? And this right here is the M1 multiplier. It is the slope of the line where we multiply the slope times the monetary base, and that equals M. And then the intercept is 0 here. Again, this right here is the M1 multiplier. Notice what happens if we assume the currency ratio is 0. So firms and individuals want to hold 0 currency. That would be 0, and this would be 0. And then we assume that banks don't want to hold any excess reserves. They're going to loan out all available reserves. We'd end up with this equation here. So we got 0, 0, and 0. If we simplify, we get the M1 multiplier becoming the simple multiplier. So the simple multiplier is 1 over the reserve requirement ratio. The M1 multiplier is 1 plus the currency ratio divided by the reserve requirement ratio plus the excess reserves ratio plus the currency ratio. And this is the slope of this equation. We have the M1 and we have the monetary base. So the monetary base goes up. This goes up because this value here is positive. This is just a line with zero intercept and this as the slope. So the multiplier is the slope of that equation. Now, we can ask questions like, what happens if the propensity to hold excess reserves increases? And one way to do that is to partially differentiate this with respect to the excess reserves ratio. And when we do that, we use the polynomial rule of differentiation. This down here, we can move it up to the numerator if we make the exponent minus 1. That's why this is minus 1 here. And then when we differentiate with respect to the excess reserves ratio, we subtract 1 off this old exponent because the excess reserves ratio is inside here. And then we multiply this whole thing by the old exponent, minus 1. So the new exponent becomes minus 2. The old exponent is minus 1. And then because this is linear inside the parentheses, when we do the chain rule, the derivative of this with respect to itself is just 1. Simplifying, we get this. Now, the numerator is positive because this is between 0 and 1. And the denominator is positive because it's squared down here. A square of a negative or a square of a positive is positive. But this minus 1 makes the whole thing negative. So what that means is the M1 multiplier will decrease if banks decide, for whatever reason, maybe because they're scared of a coming financial crisis, to hold more excess reserves and make less loans. So the effectiveness of monetary policy diminishes as bankers get more spooked. That's what this is saying. And then because we could change this E here to R, and the reserve requirement ratio and the excess reserves ratio only show up once. If we change this to R, that's R, we get the same exact partial derivative. So we can also say that when the Fed raises the reserve requirement ratio, it lowers its ability to inflate the money supply. Now, suppose if we ask a different question. Suppose we say that people decide to hold more currency. Maybe the people themselves fear a run on the banks. They fear a coming crisis. So what we're going to do here is we're going to partially differentiate this with respect to the currency ratio. And it shows up here, and it shows up down here. Remember, if we move this to the numerator, the coefficient of this quantity down here is minus 1. So the way the chain rule works is we differentiate this part of the product first, and then we differentiate this part of the product second. When we differentiate this with respect to CR, because CR is linear, this ends all ends up being 1. So we're just left with 1 times the denominator. And then this, if you notice, looks familiar. When we differentiate the second part of the second product with respect to CR, we have to subtract off 1 from the old exponent, and we have to multiply the whole thing by the old exponent. When we simplify, we get this quantity. Now, the reserve requirement ratio is usually about 10%. And excess reserves ratio in normal times is close to 0. So we have something close to 0 plus 10%. So this sum here is about 10%, or 0.1. 0.1 about minus 1 is going to be negative. So this whole thing is negative. So again, we have a negative partial derivative here. And what that means is if just after, if everything's normal, the excess reserves ratio is going to be really small. If all of a sudden consumers or businesses feel like there's a financial crisis coming, they're going to hold more currency. And if they hold more currency, then Federal Reserve monetary policy becomes less inflationary. Now, the interesting thing about this is if, say, the excess reserves ratio is 0.95 for whatever reason, and this is 0.1. Well, if the excess reserves ratio is really big, like 0.95 plus the reserve requirement ratio of 10% pushes the sum over 1. And something over 1 minus 1 is positive. So in an extreme situation where the excess reserves ratio is really, really large, initially, then an increase in currency can make monetary policy more effective, more inflationary, if you want to call it that. So, but I think under most situations, this sum is going to be less than 1. Rarely is this sum going to be bigger than 1. So rarely is this ratio here, this fraction, going to be positive. Okay, here's an example. Suppose reserve requirement ratio is 10%. Currency is $400 billion. Demand deposits are $800 billion. And excess reserves are pretty small at $0.8 billion. The currency ratio would be 400 divided by 800, that divided by 800, or 0.5. The excess reserves ratio would be 0.8 divided by 800, or 0.001. The M1 multiplier would be, we replace that with 0.5, and then we got to do it there. Replace this with 0.001, and replace that with 10%, or 0.1. And we get a money multiplier of 2.5. Now what this means if the Fed adds $1 of reserves to increase the monetary base by $1, then M1 will increase by 2.5.